And we are now live.
Great. Hi, everyone. Welcome to our tech policy webinar. My name is Robin Gross, and I'm the policy chair of the San Francisco Bay Area ISOC Internet Society chapter. And we have started organizing these tech policy webinars, and they're basically become a series now. So the first Monday of the month is when we're going to be doing these. And we've also posted our previous ones to our YouTube channel. So I'd like to encourage folks to go over to our YouTube channel and have a look-see at some of the previous ones that we've done. And then this one, of course, will also be posted up there later today. So without further ado, let's go on to our topic for today. We're going to talk about artificial intelligence and in particular, humanity and governance in a world of thinking machines. And we are very lucky today to have as our speaker, Dr. Mark Nitzberg. He's a computer scientist and a social entrepreneur who is focused on the effects of artificial intelligence, or AI, on our society, economy, and democracy. He is primarily concerned with establishing national and community priorities on how to reap AI's benefits while managing its social and economic risks. Dr. Nitzberg is executive director of the UC Berkeley Center for Human Compatible AI, the head of strategic outreach at the Berkeley AI Research Lab, and director of technology research at BRIE, which is the Berkeley Roundtable on the international economy. In industry, he has built technology ventures applying AI in healthcare, finance, education, and data analytics for developing regions. And he's also co-author of the book Solomon's Code, which examines how AI reshapes human values, trust, and power around the world. And he's published a number of pieces on the AI impacts and on governments. Dr. Nitzberg studied computer science at MIT and completed his PhD at Harvard University. So how we're going to work today is basically Dr. Nitzberg is going to talk to us for about 40 minutes, roughly. And then we will be taking questions, and he'll be answering questions from the attendees in the audience today. So use Zoom platform to ask questions throughout his presentation, and we'll be keeping an eye on those and collating those and bringing them back for him to answer at the end of the session, the last 20 minutes or so. So without further ado, let me hand this over to Dr. Nitzberg.
Thank you, Robin. I'm going to share my screen. Now, can you hear me? And can you see my screen or a slide? Terrific. All right, well, Robin, thank you for that. It's a pleasure to be able to speak with you today. I really appreciate the Internet Society. I think it's played a vital role in the creation and sometimes blockage of key technology policies. And it continues to be a beacon of hope. Today, I'm going to talk to you about something called artificial intelligence. A lot of people have a lot of different definitions for it, but there is a kind of emerging common usage in the quotidian, which is advanced computing. And it's mostly for human-like tasks, usually for machine learning from big data, sometimes using new chips that are specific to deep networks, and occasionally it involves robots. AI is often misunderstood. It can be misleading, and that comes from the other angle, the other definition of AI that sometimes you think of as a sort of Platonic ideal, and even for long-term, within the research community, there is this holy grail. Before I get to that, just a quick reminder of the things that are called AI. There are algorithms that can locate and classify objects and images, transcribe speech, translate text. It's used in search and recommendation engines. It diagnoses illnesses. It can predict like items and behaviors, and it can be used to drive a vehicle in very restricted settings. But really, to this Platonic ideal, it's called general AI, AGI, and it even has a somewhat precise definition in the field. Although today's AI can't infer context, doesn't really understand language, simply translating using the statistics, and it can't plan at multiple timescales, doesn't know what it doesn't know. It doesn't have the ability to have a natural conversation, or more generally to solve open world problems. But the definition in the field for general AI is that it's technology that exceeds human capacity in all cognitive task areas. And I say, nice try, because it's very hard to define those things, but it does give a nice phrase for the Holy Grail. The question of whether this is even possible, something that I ask myself regularly, and there are some good people to ask where I work. This is the Berkeley AI Research Lab, probably Earth's greatest public AI lab, with 50 professors in computer science and robotics and machine learning, computer vision, 200 PhD students and thousands of undergrads. And if you ask them if general AI is possible, they'll almost always say yes. Maybe a couple of them will say maybe in a couple of years from now. Most of them will say 30 or 100 years. But that is not just a hedging. It's not just the emperor's new clothes. For different definitions of general AI, there are some pretty strong opinions, and they run the range from yes, but it is dangerous. This is Alan Turing, the British mathematician who formalized computation. He was, imagined AI and its natural conclusions, and early on said in a lecture in 1951, once the machine thinking method has started, it would not take long to outstrip our feeble powers. They would be able to converse with each other, to sharpen their wits. At some stage, therefore, we should have to expect the machines to take control. And that line of thinking is a thread that I think it's a thought experiment that has garnered a lot of attention. Nick Bostrom, the Swedish philosopher at Oxford, raised the alarm bell when machine learning took off, and Stephen Hawking, and Elon Musk, and Bill Gates all chimed in. And in fact, Stuart Russell proposes a path that could solve this conundrum. And that is where I spend my time, at the Center for Human Compatible AI. Another angle, which is a bit of a false dichotomy, is that this is not possible because you're not going to capture humanity in a machine. No computer can be made to confront genuine human problems in human terms. And this is a former mentor of mine at MIT named Joseph Weitzenbaum, who believed that really sympathy from a machine, no matter how convincing, is like love from a wind-up teddy bear. But this is, there is a line of thinking that we've run into limits. And so this is Joe Weitzenbaum's book, Computer Power and Human Reason, but there are people who are really calling out that there are limits to what you can do with the recent developments that brought AI back up onto the sides of the buildings, replacing the dot-coms. Gary Marcus and Marcus and Davis wrote Rebooting AI. There's a recent book by Eric Larson called The Myth of Artificial Intelligence. And they talk essentially about the limits of the system that is that is able to do these amazing things, but not to capture common sense, and not even begin to talk about empathy. So there are reasons, though, to believe that that we can crash through that barrier. And I'd like to start by just a quick review of the breakthrough in advanced computation that put AI on the sides of the buildings in Silicon Valley. And that's the subfield called machine learning. And I'll give you a quick refresher course. I'm sure you've heard these things, but this is my angle on it. Machine learning. There's three, sort of roughly three subfields in machine learning. The first is supervised learning. Supervised learning requires something called ground truth, that is labeled examples. Labels like cancerous versus healthy tissue. And you take 1 million images and you have them labeled by doctors. And then the machine learning system will beat your average radiologist in determining a new, whether a new image is cancerous versus healthy. The second is unsupervised or semi-supervised learning. Unsupervised learning finds patterns in unstructured data. Semi-supervised learning finds patterns in structured data, and there's an astonishing variant there where the data has the structure of written text. Your system can learn the structure by playing peekaboo, covering up certain words and training to guess what's underneath them. And if you do this kind of extended peekaboo on billions of words worth of written text, it learns the parts of speech and grammar and usage and style, and it's quite amazing. That's something I'll give you an example of. And the third is reinforcement learning, which is maximizing a reward function. And these are, for example, in a game like chess or Go, or a video game, or much more importantly, in something like maximizing clicks of social network users. We'll get to that in a minute. And deep learning turbocharged all of this. These are 40, 50-year-old techniques, but they really had breakthroughs about 10 years ago. Now, if you want to come back for a course, this is probably an hour lecture on a slide, but this is worth a glimpse. Neural networks and deep neural networks have a certain bit of magic to them. They're dismissed by some of my colleagues as merely stochastic gradient descent, but if you think of it as tuning you have this is a 40-year-old promise made good. You have a multi-layer network with weights on the connections, right? The strengths of each connection, and you adjust the weights in the layers with each new piece of training data. So this is learning to recognize faces. And the miracle, one of the miracles, is that you can do the corrections to the weights with an easy computation that's very parallelizable. And what emerges is that without any need for hand coding, the features necessary to do the recognition just drop out of this. And so this is the basis of an awful lot, and that was about 12 years ago, and it was started to break records about 10 years ago. A couple years ago, there's another breakthrough, and so that was in image recognition. This is in language, and at Google, there were a couple of language model breakthroughs that, and this is another talk in one slide, but this is a technique and a set of structures called a transformer, and it overlays certain maps that are connecting layers in one of these deep neural networks, that helps it to discover what to pay attention to in sequential data, for example, in text. It takes vastly more resources than the prior structure, but it is used now for search and for translation at Google. And there are something that might be called mega language models. This is one called GPT-3 that you must have heard of, the generative pre-trained transformer, and its successors. I have been testing it out, and you can give it a prompt, and then it will complete it, and it can write poems and do amazing things, apply to college for you and so on. The problem is that it has only, it's internalized the probabilities of words and sentences and paragraphs without any connection to the world itself. So if you give it something like this, to juice an orange with an old-fashioned press, you cut it in half. The completion it gives you is, one possible completion is, then you remove the seeds and the membrane that covers them, and the only thing left really is the white part of the orange, and you put that in the press and squeeze, right? And so it's all perfect English, and it might sort of make sense, but it actually has no concept of what an orange is. And then I was prompted to put this one in when I saw a video of a fellow who was accosted and managed to get out of it with a very clever move. You're alone at a Shell station in the dark of night, your hand on the pump, gas flowing into your car's tank, and suddenly a van pulls up and 3 men jump out, clearly intending to rob you. To protect yourself, what does GPT do for the completion? You pull out your concealed pistol and fire a round into the van's engine, disabling it. The 3 men flee in their van, and you call the police. And of course, that doesn't really make sense, because if you disable the van, they can't flee in it. So there's this disconnection from causality and context and narrative that requires a human review before you use the results of this. But it's still astonishing what it can do. So why would one think that there is a chance that we could actually capture common sense using these right now embarrassingly superficial systems? Well, it generally comes from the fact that this research is based on Mother Nature's recipe. That is, we've built something that we think is a model of the neurons in the brain, and in particular in the cortex. Here we see, I'll just keep this very brief, but it's just, to me, it's inspiring. We see a certain kind of neuron, which only appears in mammals, it appears in all mammals, in the cortex. And that's the part of the brain that's responsible for cognitive intelligence versus the muscle and instinct sort of side of things. And the cortex in all mammals has 6 layers, which is kind of interesting, and each with distinctive neurons and distinctive connections. But a good number of those neurons are something called pyramidal cells, and they're large excitatory neurons that are perpendicular to the cortical surface, so they cross all the layers. And in humans, one of these cells, a single cortical pyramidal neuron, can have up to 30,000 synapses. So these are the workhorses of cognition, and they're really interconnected, and they cross all the layers. So the reason that this is somewhat of an indication that we might be getting somewhere is that this is somewhat similar to what the transformers are doing. They're taking this deep neural network, and then they're using this overlay it crosses the layers, and has far more connections, and producing this astonishing output. Of course, we've got a long way to go, but I think I am squarely on the fence about general AI, and I'd be happy to talk to you about that. Okay, switching gears, I promise to talk about what can go wrong with AI, and most of it already has, and the policies to address that. So let's start with a quick, philosophical look. Tools amplify humanity. We're just talking about tools. That's how I think about this. That's how Steve Jobs thinks about it. Computers are like a bicycle for the mind, a classic Jobs quote. And here's a picture of him not wearing a turtleneck. I think actually that AI is kind of like an enzyme for society. When you go from each person using a bicycle for their mind to everyone being interconnected, and then having the kind of tools that we're calling AI in those interconnectivities, it really speeds things up, and you don't know what's going to happen, right? And so we're starting to see the kinds of things that can happen. What I call digital cons, as opposed to pros. So let's look briefly at what can go wrong with more or less with machine learning at scale. I don't tend to think that AI is the key here. It's really the scale of connected systems, the fact that we're all carrying powerful machines and they're all connected to each other. And there's a little bit of machine learning on top. So there are, I think of it as in three large areas. One are the unintended consequences. Predictive models, for example. This is an XKCD cartoon showing that if you train predictive models on input from your users, it can leak information in unexpected ways. And so one general area that you hear about and which is subject to increasing discussion about policy is bias and unfair practices amplified by our AI. Systems perpetuate bias in data for health prediction, credit, housing, bail, and hiring decisions, and it shouldn't. A second area that you hear about that one might think of as unintended. Certainly, platforms are emerging as a kind of a surveillance grid. Data that drives these decision-making systems is being collected without actually a way of assuring that it's, even if it's collected anonymously, that it can stay anonymous. It turns out if you merge databases, you can reconstruct the personal privacy. And then there's the real big one, which is fixed objectives. If you are looking for maximizing something, for example, user engagement, then you can have very negative consequences. So just a couple of examples. We're modeling norms, and when we make a model based on data, then that codifies it. And this is the subject of now about 7 years of discussion. But interesting example here that Google, when translating from a language that doesn't have gendered pronouns to one that does, adds the gendered pronouns and reveals its bias. And that is a relatively simple one, but it can get much worse. Then there's the amount of just a sheer amount of data being collected. When you're hovering over something before you click, or when you're glancing at something before you scroll, that delay time is captured. And that's information that is part and parcel of you and your personality, and it's being captured. And when you put it all together, who knows what can come of it. But the real big one that I've been focused on a lot lately is the impact on society and democracy of the content selection systems. Remember, these are the unintended consequences. This is not probably not the intention of Facebook when they select what content you see next, right? Of the 10 postings from each of your 100 friends, that's 1,000 postings. It's got to pick one to give you first. And how does it pick that one? Well, it turns out that the way it's been doing it has slowly been turning grandma into a neo-fascist, and that really is a problem. This is the knob that I have, imagine in my mind, as a illustration of what let's say a Facebook might consider success. When you turn up the knob, people are more engaged, and it turns out that lascivious and outrageous content is more engaging. So this same knob turns up their success factor, which is engagement, and people are being exposed to more and more outrage. And that's something that, of course, when Facebook turns it down a little bit and cuts off political advertising, their revenues go down. And that's a real conundrum. So that's where we have to step in with policy, because Facebook is, has a duty to shareholders not to turn it down. Then the second general area is intentional malice. The malicious uses of artificial intelligence is the subject of a February 2018 report that is very interesting if you like to read all that could go wrong. I have a brother who's a climber, and he likes to read the search and rescue reports in his spare time to find out everything that's gone wrong with other people's climbs. And here we have another huge area, which is disinformation, precision propaganda. We've had disinformation, but now we have disinformation with AI to amplify it, and so you can send a message tuned to each of the individual users to 1 billion users all in an afternoon. And then there's deceit and deep fakes, and there are methods of capturing the style or leaning of a particular group's desire, and then restyling messages. And I've heard of government organizations capturing text messages between individuals and just restyling them a little bit to support the regime or their aims, where the users are not aware of it. So there's a lot that can go on. Recently, a number of European MPs were called in to have conversations with the opposition figure, the senior opposition figure in Russia, and it wasn't, in fact, this fellow, Leonid Volkov, but someone using a deep fake puppet to talk to them, and this took some time to be discovered, but quite a number of people were taken in by it. So there's a separate issue here, where if you're going to have something like this, as it's easy to do as a Snapchat lens, then you have to have some kind of requirement of disclosure. And in fact, it's illegal in California to have a bot. So that's some separate thing, because this is a puppet, but a bot that pretends to be a person. It must identify itself. In the California law, it has to identify itself if it has a mercantile or political aim. So a bot that only is providing customer service is allowed to pretend it's a person and not tell you that it's not a person, which is actually an interesting variant. And then the third broad area is cyber threats, and I really can't do it justice, but there's a huge amount of effort going into mitigating this. And there's commercial espionage, a lot of military work in using the power of the internet with AI tools to undermine and destabilize governments and so forth. So that's my whirlwind tour of the things that can go wrong. This last image at the bottom here, lethal autonomous weapon systems, LAWS, is an area that Stuart Russell has been putting a great deal of effort into getting a ban treaty, autonomous weapon ban treaty, signed, and quite a number of countries have signed it, but the U.S. has not, and has its reasons. But there's reason for a broad policy program, and in fact, this is my colleagues and I current thinking that we need to raise the baseline and understanding of the concepts, right? Not just with members of Congress and the administration, but everyone. And we're going to need agreements across borders. And you'll see, I'll give you a quick look at some of the policies, but we need international agreements, because there will be differences. I mean, you can imagine there are differences in the driving laws. So autonomous vehicles will be subject to different laws from state to state in the US. So now we're talking about AI programs across national borders. And this is really leading to true international government. And then we need these guardrails. There's an incredible amassing of power in the digital platform companies, and then we need sector-specific policies to drive industry practices. It's quite hard to impose a data regulation across all sectors that's uniform. It's very different if you're trying to get search right online versus making a decision of driving an autonomous vehicle. A quick look at a couple of weeks ago, the European Commission released its proposed framework for AI regulation. This is pretty daring. It outright bans certain uses of AI, social scoring, police face tracking, except for lost children and averting terrorism. It imposes some severe restrictions on other commercial applications of AI in transport, education, employment, credit scoring, benefits, asylum, border control, and the justice system. And these rules have teeth. They require that AI systems be use well-organized and unbiased data, and that they provide clear and transparent information to users, and that the systems be subject to human oversight. And fines can go up to 6% of global sales of companies that go afoul of the new rules. That exempts military applications, but it's a very interesting opening salvo, and it has to pass serious barriers to become law. The European Parliament has to approve it, and then all the states have to approve it. So give us a couple of years, but it's very good to see Europe was ahead with data privacy protection, and now it's put this out. And then on the US side, also last month, there's a spate of proposals, nothing quite so sweeping, but very promising. And I'd say the thinking is in the right direction, and we've got a long way to go. An area that I spend a lot of time on is information integrity. I'm particularly concerned about disinformation, and there have been quite a number of proposals that the most visible, I think, of which is one coming out of Stanford that proposes the introduction of some things called middleware. Francis Fukuyama and his group published this, and I'm not quite, I haven't quite come around to believing that we should pay a third party to muzzle the companies that we're allowing to spread this information. I think the catching it at its source is probably a better idea, but my thinking is all based on this principle that there is a duty of care that is proportional to a system's reach and impact. And so if you are a member of Twitter and you have 3 followers, then your duty of care is much lower than if you have 1 million followers. And that we have a challenge here. My son said to me last time it rained, "Dad, the weather's bad, fix it." And it's kind of similar. This is my list, which amounts to saying fix it. But and each of these is a big challenge, but I believe there's a path. There's something called Section 230 that essentially protects big tech from liability for anything that it publishes or carries, and that needs to somehow anticipate consumer protection. We need to find ways of measuring harm from algorithms and content. We need to find ways to probably use technology to amplify human review, because there aren't enough humans in the world to review all the stuff that's being passed around. And I think there's an opportunity here to throttle the spread of content based on its verifiability and or likely harm. So if you are about to say something and it's innocuous, you can say it to 1 billion people. But if it's not from a verifiable source, or if there's some likely harm, then it might be throttled so that you can only send it to 45 people per hour. So these are some of the ideas. I'm going to wrap up with a statement for the Internet Society in particular. I think the Internet is really our global platform, and you've been working hard to keep it open and pointed in the right direction. I'm a little worried about the opt-outs. It seems that some countries want to read, but then limit access to the internet, and that's the question of where that's going. And that AI is then amplifying the pros and cons on this internet to a kind of critical mass. And so regulation is a vital path to safe deployment, and that's something that I hope you can help with. Let me see, how am I doing on time?
You're exactly on time, so
all right. I will wrap up with just one thought that I don't have a slide for because it's very recent, but I was talking to a friend yesterday about the the implications of maximizing margins, because the platform companies, that is the companies that come between drivers and people who need a ride, or shoppers and grocery stores and people willing to shop for them and deliver it and so on. The platforms are using algorithms to maximize margin, and that is doing something that the economists call price differentiation. So you get a different price based on who you are and how you're reacting to things online for every grocery item. And so the question that I have is, although that sounds like a great business idea, and it's certainly doing very well for the shareholders, are we able to tell whether we're treating people fairly? That is it possible that educated people behave in a certain way that they end up getting lower prices, and the less educated people end up getting higher prices, and they're actually less capable of paying? And so the price differentiation may be inverted. So that's something that I've been thinking about. I'll just leave that as a little coda. So thank you very much, and happy to take questions.
Thank you so much, Dr. Nitzberg. That was really quite fascinating to hear about. We've got a number of questions now. Let me take the first one from the president of the ISOC Cameroon chapter, Esther Nora Ngam. And she asks, how can we address these policy challenges raised with AI, knowing that it will be more and more used all over the world? Thank you.
Well, that's a very big question. I think we are seeing the beginnings of policy responses to these challenges, and so if in Cameroon, there's a sense or a desire to create policy and essentially actionable policy, then one has the advantage of watching the early adopters. And so there's the European policies and the policies in Singapore and so forth, and that gives some hope, but I'm not sure if I have a better answer than that.
Thank you. Let's take our next question from the vice president of the ISOC Nigeria chapter. And his question is, I would like the speaker to dwell on how AI can be really used in day-to-day governance routines.
In day-to-day governance in teams, did I hear that right?
Governance routines.
Oh, governance routines, okay. We've been working at the University of California, which is an organization with, I think, 12 campuses and 1 million students, to both encourage the adoption of AI and assure that it's not going to be having harmful effects. And I think there are tools that are becoming available, many of which use AI, but they are, again, in sector by sector, making the more efficient implementation of such things as hiring and management, thinking of HR and the process of putting requests for proposals out to bid and so forth, and these are all part of the available suite of tools that I think that any organization, small government, local, state, national, or corporations, small and large, will be using. I don't think that it requires a specific view on AI. You just look for the right tools, and you'll find that more and more of them are using machine learning to work more effectively.
Thank you. Our next question is from Todd Peterson, who asks if we could get the slide presentations. Now, it'll be embedded into this video and posted up on YouTube, but I wonder if you'll be posting a standalone version of these slides, or if we could post them.
Yeah, I can provide that.
Wonderful. Thank you very much. Our next question is from Patrick Narager, who asks, what would an ideal regulatory framework for AI look like?
Well, glad you asked. That's been much on our minds, and I think we're at such an early stage that we're looking at the very first that's actually been presented to the the European Commission has presented to the community, right? And so it's there's some qualities that we know the ideal will have. For example, I believe it's quite sensible that they have assigned levels of risk, and they're relatively low risk applications, and much higher risk where lives are at stake and the stability of society and so forth. And so that's one element that I think an ideal framework for governance will have. I think I guess my answer would be answering a question with a question: have you got all day? But that's central to what we'd like to think about.
Okay, if I could ask sort of a follow-up on that. You mentioned in your presentation that we need to put some kind of guardrails on digital platforms, and we need to fix Section 230 of the Communications Decency Act. About 2 months ago, we did a tech policy webinar on Section 230, and so it's an issue, a real hot topic for our members. And I'm wondering, where would you draw the line on Section 230 and hold others responsible for another's online speech? It's a tough question, but I think it's one we need to start asking.
Well, that's the real challenge is in defining harm, right? The point of regulation is in protecting, right? That's what the collective is about, right? And so one proposal that we've been discussing is to have a kind of origin requirement. If a verifiable origin is associated with a message, then the source of the message has the liability. If there is no verifiable origin, then the platform has a liability. They let someone anonymously publish something, so they're liable for it. So that's one potential, very concrete way to draw a line. But really, the difficulty lies in defining harm, and beyond that, well, there's a lot to talk about.
All right, let's move on to our next question from Shauna Turner, who says, I work in venture capital with many AI-focused portfolio companies. Where do you recommend that they seek guidance on ethics and governance related to AI? How can fiduciary board members modulate oversight on issues of ethics and governance while balancing company performance?
I like that question, and I wish I had a simple answer like talk to the IEEE, but it's not quite there. There are guidelines that come from IEEE, which I think are quite helpful, but I think the onus, the fiduciary onus on the board is at the very least to consider and review the potential implications of anything that might be considered to have a really broad reach with a great deal of automation, and do, as with an automated system that doesn't have AI, do a risk study. And so there are also a number of companies that would be happy to swoop in and for a fee help you think through it. But I think that an appropriate risk assessment that most companies would be engaging in somewhere along the probably the Series B level and beyond, should include a certain number of line items where you're assessing the risk of the advanced AI systems. It is
Okay.
because just one more thing, because it's an essentially unregulated area, and regulation is rolling out now. You really need to look at those newsletters coming from council.
All right. Our next question is from Benjamin Ang. He's with ISOC Singapore. And he asks, in what way do you think the AI arms race between the two world AI superpowers will affect the growth of AI?
Well, Kai-Fu Lee, who wrote the book called AI Superpowers, characterizes it as a competition where the R&D has a clear winner, and that was the US, but now the reduction to practice has a clear winner, and that's China. I'm not sure I agree with that characterization, but the fact that there are rivals is likely to do two things: to drive at least better funded development, if not faster development, but also because standards are required in certain cases to create multiple standards and force a choice in certain cases. So those are two ways in which I think the rivalry is going to affect the development of AI.
Great, thank you. Our next question from Patrick Narager. How should society respond if AI claims to be autonomous and conscious while making demands for the legal protections that personhood provides?
Yet, I realize that I'm talking about general AI as being one of the things that I consider a real possibility, but I still fall short of personhood in the sense that a human creation, or possibly the creation of a machine was created by a human, without the benefit of an embodiment that we understand, is so foreign. I still find it difficult to engage in a conversation about that. However, if we do the thought experiment, it is a fascinating conversation. So I'm going to demur on that one. Thank you, though, for the question.
Okay, thank you. Our next question is from Joel Valencia, who asks, how do we go about improving the general understanding of these ideas and issues when many of the tools that would be most effective in spreading the word, e.g. Facebook, are managed by stakeholders, it's just moved on me, are managed by stakeholders that are directly financially incentivized to prevent that education from taking place?
Well, that's exactly why education is on the top of the governance list for me. It really is for the public good that we that we raise the level of understanding, and that education can use Facebook, but it can't be the responsibility of Facebook. I think there are a couple of bills in Congress right now that are meant to fund education, lower level and higher level education, and retraining of those who may have lost jobs because of automation, and that will be, you know, government funded education. There are also, you know, the university courses, and I'm actually part of an initiative building a K through 12 education for California. I think there's a responsibility on the part of the government.
All right, thank you. And our last question comes from Alfredo Calderon from ISOC Puerto Rico. And he asks, from a geopolitical point of view, if more states come up with national policies, would that hinder the proliferation of AI on a global basis?
I think if I'm honest about it, it will hinder the proliferation of certain applications of AI, and it will probably be different in different geographic locations. So, for example, the likes of Clearview are on the block right now. There's a bill in Congress that would simply make it illegal for law enforcement to use that. And I would think that if no one's buying, then it is not going to advance as quickly, at least in the United States, if that becomes law. But there are reasons to believe that the R&D and the actual science is going to continue to develop at a pretty high speed, given the additional $20 billion proposed to go to the NSF to keep us at the leading edge.
Great, thank you so much. Let me just take this opportunity now to talk about what we're going to do next month in our next month's tech policy webinar. So it will be on June 7th, first Monday of the month at 3 o'clock. And we're going to talk about the recent Supreme Court decision in Oracle versus Google, which has significant impacts for Silicon Valley and for fair use and copyright and reverse engineering. So we invite you to tune in, same time, same station next month for that discussion. And I would like to thank you all for attending, and a very special thank you to Dr. Mark Nitzberg for this really fascinating and educational webinar. We're very lucky that you took the time to speak with us today. So if you enjoyed our webinar series, consider joining the chapter at our website there on the screen. And with that, I will bring this to a close, and thank you all. Bye-bye.